oil and gas and increasing the yields from existing reservoirs. The first high-flying stock, high-tech stock, in the 1965 was the IPO of Sam Wiley's University Computing Company. This was a time-sharing computer company that grew from zero to like $60 million in revenue in a short period of years. Why? Because even for rich oil and gas companies, computing power was too expensive that they couldn't afford to own computers. They had to rent them and time-share them. So, the next chart, please. So it's astonishing how much progress remains to be made in the energy business. This is the chart that made me understand U.S. seismic. Up until 1980, the ratio of dry holes drilled was 7 feet of dry holes drilled for every 1 foot of productive hole. In 1980, with the invention of the microprocessor, affordable workstations were possible. So a company called Landmark Graphics came out with a very fast processing station that was able to quickly process seismic data and affordably process seismic data. And as a result, we hardly drill dry holes anymore. Now, the next slide shows that not only was seismic and the processing power important for reducing dry holes, it was also important for increasing the yield from the existing reservoirs. So this is BP Shell data, and before 1980, the technique was 2D seismic, and you looked at slices of the reservoirs. And what you could see is that about 25% of the oil was recovered before the reservoir was considered depleted. In 1980, 3D seismic came out with Landmark Graphics. It was acquired by Halliburton for $500 million, but the yields were improved to 40%. And the dream of the industry is that, and this is BP Shell's data from their Fohaven field, was that the use of permanently embedded sensors in the reservoir could enable more perfect information instead of just snapshots and three-dimensional images, actual real-time moving pictures of the reservoir. That's extremely important for enhanced oil recovery. It's also very important for being able to do things like seismic while drilling. So the dream is that with these permanently embedded sensors, that you can get 65 to 75% of the oil out of the reservoir. And that's profoundly important to the economics of the industry. So the current state of the art in seismic sensors is electronic and copper geophones. These have a lot in common with the telecom world of 25 years ago, before fiber optics were introduced. And Jim and his team actually were very important in developing the key enabling technology, the erbium doped amplifier, which was the enabling technology for fiber optics. So incremental improvements made in these legacy systems cannot deliver the performance requirements for the industry needs for 4D seismic. There's a real fundamental problem here. In order to enable them to dynamically visualize and manage their assets in the reservoirs, so it's hard for us to understand the profound impact of the successful commercialization this technology will have on oil and gas industry. So just as Sprint in 1986 developed the first nationwide fiber optic network, the value proposition was so silent you could hear a pin drop. Well, that wasn't at all the benefit of fiber optics. It wasn't the more clear voice that you could hear. It was now all of a sudden you had these huge dark pipes that you could put huge amounts of data inexpensively. And what this did was it enabled the development of Amazon and Google and eBay and Facebook. So all the technologies that are now transforming our society in the digital world were made possible because of this revolution in fiber optics. And we believe that the same revolution is going to happen in oil and gas when these sensors are transformed to fiber optics. So if we have to say, if we have what we say we have, and Jim will be talking about that subject at length here, and the industry adopts our technology, it has substantial geopolitical implications. So the U.S. Department of Energy estimates that if permanent sensors are embedded in only 10% of our reservoirs, that this could be used by the oil industry in the U.S. to replace 10 years of OPEC imports. This has very profound implications. And also the controversy surrounding the environmental impact of fracking has raised the profile of the industry to government and regulators. So we believe that U.S. seismic technology can reduce the environmental profile of the unconventional resources and can improve the productivity of the industry and ultimately reduce the cost of energy. So it's important that Congress and federal and state regulators understand the implications of our technology. So Jim has had a long and effective career at engaging and interacting with Congress and obtaining financing for his past projects. And we have hired Kent Leacock as our Senior Director of External Affairs to help leverage his relationships. So we've experienced some early successes of this investment in time and effort, and Jim will be testifying in front of the U.S. House Subcommittee on Energy and the Environment tomorrow. So our voice, added to those of our customers, will help government implement smart regulations to ensure unconventional energy revolution remains environmentally safe and in a productive way. So in conclusion, looking back at history, our economic and technology historian, a guy named Brian Arthur, said that the size of the US economy in 1850 was the same size as the economy of Italy. It was very small. But then 40 years later, the US economy was the world's largest economy. What happened? Across a continental rail system was developed, the Industrial Revolution, the US economy developed muscles. So the same digital revolution that we're talking about today is enabling the development of a neural layer in our society, which we believe is also going to trigger an unprecedented economic expansion and completely unanticipated. And we think that US Seismic and the work that Jim is doing is going to be a huge enabling factor of that. We think that energy can be inexpensive, safe, cheap, and reliable. And Jim, I'd like to ask you to tell us more about it. Thank you so much.
So I like to walk around when I talk, so I'm switching to this other mic. And could you go to the third chart, the next chart, after the wave? Next, okay. So before I start, I want to introduce some of the people here from US Seismic Systems. First of all, we have Alexandra here up front, and she's a marketing specialist with us, and she's agreed to switch the slides for me. I had a super fancy one, but it didn't seem to work here, a remote switcher. And is Kimberly? I don't see her. Well, Kimberly's, I don't see her here, but she was up front. She's our human resources manager. And then I have Howard Wilkinson in the back. He's our VP of sales. So here's kind of what we're talking about. I'll give a presentation on an update on the revolution in the energy industry. And I'm not the only one saying that, and I have a video I'm going to show you that I thought was perfect. I mean, I couldn't have made it better myself. It was made by the House Energy and Commerce Committee, so I'll show that in a second. And then, but there are some roadblocks to this energy revolution, and we think we're the solution for these roadblocks. So we're going to show how we're positioning ourselves as the solution. We'll have lunch somewhere around 11:30. And around 12:30, we have a bus that's taking everybody to our facility for a tour. And around 2 o'clock, the bus will bring everybody back to the hotel. So if your cars and stuff are here, we'll bring you back. I have this magazine here, Fortune. I'm putting this presentation together, and you just can't help. Every place you go and you look, you see this stuff about natural gas. And this magazine comes across my desk like a week or so ago. And Fortune magazine, they call it the United States of Natural Gas. They have the Statue of Liberty with a gas thing coming out of it. Shale gas is reviving the economy. Why oil giants love natural gas. So this is huge, and it is really a revolution. And so what I'd like to do now is show you a video that was put together by the House Energy and Commerce Committee. And I don't know if I told you how to do this, so I'll come over. So I thought that was very apropos for our meeting. So you go to the next slide. So now this here is interesting. So, about a week ago, Kent comes in and says, Jim, the Congress wants you to come and testify before a subcommittee on energy and the environment. I go, Congress of the United States? Kent says, yeah. I said, wow. Okay, and so, the problem is that we said, okay, but we have this meeting here, and they want me to be there Thursday, which is tomorrow. And so I go like, wait a minute here. They want me to come and say how to Congress, U.S. Seismic Systems, fiber optic sensing systems, how that's going to help out the nation's energy industry and make it more environmentally safe. I go, of course I want to go talk to these guys, right? So I said, we'll figure it out. So I have an apology to make. At noon, I have to leave to take a flight. So the tour will be led by Howard, our Vice President of Sales. So I'll bug out at noon after this presentation and lunch, and Howard would be leading the tour. Okay, next. So a little bit of an update on the energy revolution. Next slide. I put this up because, people have been in the energy industry for quite a while. Remember that, back in the 1970s, they hit this thing called peak oil, and it was all said that, production in the U.S. is on the decline, and as, it'll just keep declining, as years go on, and we're going to have to start importing more or doing other things. But, you take a look at these two charts, and you say, something happened there right around 2007, 2008. All of a sudden, this stuff's starting to go up again. Like natural gas is going up, oil's going up. Like, that wasn't supposed to happen. What's going on? And it's, a new technique was introduced for horizontal drilling, being able to, go in and then find a pay zone and drill horizontally through it and fracture it to release oil and gas. And they call this unconventional energy, tight gas, tight oil. But the bottom line is, new technology changed the decline, and technology provided an answer such that now oil and gas production is going up. Nobody would have believed it, and it's going to continue going up. So talk about like 2010, shale gas was 23% of our production, and it's supposed to get up to about 50% in 2035. And shale oil, same kind of thing, in the lower 48 was about 21%, and they expect it to be 31% by the end of 2035. Next slide. I put this up, and I really want to say, you see all this stuff about game changing. The game basically has already changed. You look at Shell, one of the biggest oil companies in the world. The first time in its history, they're going to produce more natural gas than oil. That's amazing. And then, here's another article, and they talk about Rex Tillerson at